Our talk on Kubernetes admission controllers. My name is Morgan. I'm here with Srini, who works together with me at IBM on open source projects as an open source contributor. Today we want to take you through an overview of admission controllers, discussing the history and a sort of classification of admission controllers so that when you encounter them you understand what they are and the different organizations. We're going to start with the history, and then we'll have a high-level overview of the admission controllers, followed by a deeper sort of code view into what you see when interacting with them or developing your own. And so to start with, what is an admission controller? In abstract, it's a way to validate or modify objects as they come in before they are persisted to the database, which for Kubernetes is etcd. In a technical sense, for the built-in compiled-in versions, they're implementing the Go validation interface or mutation interface. We'll look at that and what that is. And for the webhooks, they take in an admission review object and look at the admission request and output an admission response. Next, okay, and so the history of them. Admission controllers basically have been since in Kubernetes since nearly the beginning, and the first was pulled out first in 0.09 to separate object validation into a pluggable interface, as well as allow other plugins to exist in the future. The first webhook started out at around 1.4 and existed for specific API types to call out to specific web servers, and were not sort of as configurable as the generic webhooks are today. And so we have into V1.9, we have the separation of both generic webhooks and mutation, and this allows configuration to look at any objects as well as a specific formalization of the ability to modify the objects as they come in. Everything that exists today comes from is V1 now. It's not alpha or beta anymore, and exists in Kubernetes from 1.16 onward, which covers most of the currently supported releases. So despite our title being taxonomy, you can sort of historically go back and see the history of how these evolved, but it's easier to classify them into sort of this Punnett square type object where you look at whether it's compiled in or a webhook, and you also look at whether it's validating or mutating. The built-in validating webhooks are some of the earliest validating admission controllers, built-in, compiled in, are some of the earliest ones that are available. And then the webhooks came in to validate sort of allowed images. That was one of the first webhooks. Mutating came somewhat later, one of the first ones being pod presets, which allowed users to create a configuration to modify pods as they arrived. And then the last, and I think the most interesting category, would be mutating webhooks, which are most useful for CRDs, and in that it is the only way to validate and apply defaulting for CRDs. And so there aren't any provided by the code, but there are integration tests that use a testing one called AGN host. And that is what we will look at later. And now it is Srini's turn.
Thanks, Morgan. And I would like to talk about what admission controllers are, give you a good overview on everything we know about them. So what are admission controllers? First of all, in Kubernetes, controllers are control loops that watch the state of the cluster, and each of these controller tries to move the cluster state to a desired state. Admission controllers, on the other hand, are plugins that govern and enforce how the cluster is used. They are nothing but interceptors to the incoming API call. Their execution defines and customizes how a cluster operates. Admission controller webhooks, on the other hand, are simple HTTP callbacks, and admission controller webhooks are, like I stated, mutating as well as validating, or special controllers compiled into the API server. There are many other plugins compiled into the API server. These plugins can respond to the incoming create, delete, modify kind of requests on a resource in the Kubernetes cluster. Many advanced features in Kubernetes require an admission controller plugin to be enabled in order to properly support the feature. As a result, Kubernetes API server, which is not properly configured with the right set of admission controllers, may be an incomplete server and will not support most of these features. Let's look at the flow of an incoming request. As a request comes in, authorized and authenticated properly, it will go through a mutating phase where any mutating built-ins as well as custom webhooks gets executed serially. And then those will affect the incoming object's spec or make modifications to the spec, and eventually goes through an object schema validation where the spec is validated for the object, and goes through a validation phase where a set of built-ins as well as webhooks validates various fields in the incoming object. If everything goes fine, it gets persisted to the database, etc. If any one of them fails, the request can get rejected. As you can see here, it used to be minus admission control flag that was set, got deprecated in 110, I believe, where we used to present all the webhooks in an orderly fashion with mutating admission webhook and validating admission webhook being the last two. But with the new flag, enable admission plugins, there we don't need any order. And each of the API servers set these set of flags as on a required basis. Like, for example, if you need to read through the documentation of the individual providers, like, for example, IBM Cloud here shows you the set of plugins that are enabled. Similarly, every cloud provider may have a different set of plugins enabled. Main function of the built-in plugins is to provide security, governance, and configuration. For example, some of the plugins, built-in plugins that I have mentioned here, default storage plugin adds a default storage class to an incoming storage request if the storage class is not specified. Limit Ranger, on the other hand, sets a default limits on CPU and memory within a namespace if they are not specified. The interesting part is always pull images here, which will protect your private images in a multi-tenant environment, forcing every other user to provide proper authentication and pull your images if they want to use it. So let's move on to validating admission webhook. When all the matching webhooks are found, they are executed parallelly. And if any one of these webhooks fail, the entire request gets rejected. No mutation can occur because this is the last and the final phase, as we saw, which is the validation phase. You can see the rules are based on operation scope. Scope can be cluster or namespace. As in the example here, I have V1 created on the pod with a namespace. There is another flag we can opt in, webhook configure to use an object selector, which will skip the calling of the webhook if the label matches as depicted here. On the other hand, looking at the mutating admission webhooks, they are called serially. Let us talk about the requests coming in. These are HTTP callbacks, like I mentioned. Admission review object is presented to the webhook, which contains a UID, universal ID, and the resource object that needs mutation or validation, right? In the case of mutation, the response should contain this UID, which is presented to it back, and then a flag called allowed, which is set to true or false, depending upon whether the webhook is accepting or rejecting this request. And then for a mutating webhook, a patch is also returned. Before that, I want to say in case of error, the webhook should return a proper HTTP error with a nice user-friendly message like use signature missing in the incoming pod annotation, whatnot, whatever you figure is missing from the spec, you should clearly state that. So for example, on the patch and the patch field type, which is always going to be JSON, the patch will be a serialized array of bytes of the JSON string. If suppose you got incoming deployment, you want to set replicas to 3 if there are replicas missing on the deployment, you would send a patch back saying that op is add, path is /spec replicas. So we are adding that field with a value of 3. Idempotence is important for webhooks because webhooks can be called more than once. If there is a patch that is changed by more than one webhook that is observed, and then your webhook might be called twice or more. Ordering is not guaranteed. Any webhook can be called in any order. And then matching request is a field that has to be set to exact or equivalent. Equivalent is preferred. The reason is, let's, for example, we talk about our deployment case where we're setting the replicas. As you know, APIServer allows creating and modifying deploying objects with different versions and API groups. So if deployment comes with v1 apps/v1 or apps/v1 beta 1, both of these should have the same effect, and we should be able to add the replicas. So that means that in order to achieve consistency, we should set this field to equivalent. Timeouts is another aspect I want to mention. Webhook latency adds to the API latency, so set the timeout to any value between 0 and 30. Mutating and validating webhooks should work hand in hand. That means a mutating changes certain aspects in the object, and then the validating validates them. Side effects is a field that can be set to none, some, none on dry run, so on and so forth. If you are doing a dry run or a failure happens in the middle of the request, you have to make sure that your webhook reconcile all the changes it has made to the cluster. Namespace selector is required to avoid running webhooks in the system namespace, which may have unexpected behavior to your cluster. Reinvocation policy is set to never, or if needed. This depends again on your webhook. Basically, if you want to run your webhook such that only once, so you can control that during this using this field. Path presets is a built-in, which is mutating. Actually, it will inject information into paths at creation time, such as secrets, volumes, and volume mounts, and etc. Path presets apply by labels on the path. For example, as I shown in the example here, a path coming in with a label front end will be actually affected because we're going to inject an environment variable DB port as well as volume mounts in there. If a pod preset fails to merge, the pod will still get started. There can be n number of pod presets run on an incoming pod, and at the same time, a pod preset may affect n different types of pod requests. All containers in the incoming pod object or even the pod spec may be affected by the merge. You can turn it off using a flag here. So at this point, I think I would let Morgan dig deeper into the code and show you how the admission webhooks work. Thank you.
All right. Let's talk about the built-in compiled and admission controls. Thank you, Srini. We're going to look at some code details now so that you are, again, aware of the behavior and the existence of some of the compiled-in ones, and such as the always pull images that we've discussed. We have, hopefully, the package, the plugin directory, which has all of the admission controllers in it. And in it, we can look at the always pull images controller, and we see the code, and we see the admission.go, which is where the code is located. And inside of this, we can see that we implement the mutation interface and the validation interface as discussed. When we look at that, we can see it that the mutation interface is, when we look at the mutation interface, we'll see that it is coordinated with this admit function, and that the validation interface is coordinated with the validate function. And if we remember the order, we can remember that mutating happens before validation. And so for our mutation, we can see that the always pull images sets the image pull policy to pull always. And we can see that the validation side of this checks that that is set. Other thing important to note is that when we're past the object from the passed in, what we get is always going to be a pointer to the object, because you have to modify the object directly before it is persisted. So we go back. So now, mutating versus validating built in. Remember that the abstractly validating simply says yes or no, proceed or don't, accept or reject. Again, it implements the validation interface, whereas the mutating implements the mutation interface, and this allows access to change the object. And as I mentioned, you're going to get a pointer, and it's important that you modify that object directly, because that is what gets persisted by the storage layer, which is etcd. And this differs significantly from a normal controller, where you often have a layer of caching involved, and you want to make sure you do not modify that, because the caching layer will not be aware of you writing to it and won't write it back, and so you can blow yourself up that way. So you need to be careful. So if we go back to it, we can see the mutation interface here. You can again see that it implements, they both have the same interface, which is just a handler, and so obviously it's sort of a plugin, and so the plugin is called as handle. But once inside, we detect whether or not it's mutation or validation. We call them in the appropriate order, and they get called with these specific functions. Now we move back to webhooks, and webhooks are, again, a REST API, which both mutating and validating will get an admission review object in, and inside of that admission review object is going to be an admission request. And both validating and mutating are going to look at that request, perform some logic, and then, as we previously discussed, write back to the admission review and admission response object, and copy the UID from the request, copy the UID from the request for both of them, set allowed to true if they validating or mutating agree that they want to proceed, and then the mutating will also contain the described JSON patch change to the object. And so bring that up. And so we look at the admission review struct, we have the admission request, we have the admission response. And so inside the request, we have the UID, and that is where we're going to copy it from. And we'll also have the object, which comes in. And this is, again, you're going to have to deserialize that into an actual object to operate on. And then once you have decided what to do, you will write your patch out. And you will copy, as it says from the documentation here, you copy it from the request, and you will set your allowed to true. Okay, and now we get to the point where I discuss the AGN host image, which is the demo portion. So we'll go back to our screen. And so in the Kubernetes testing environment, there's an image provided called AGN host, which is a very helpful image to use for testing, but it is also a very good example of the intricacies and the implementation of a webhook. And webhooks, again, as we mentioned the configuration earlier, SSL, and so we'll have to provide a server that provides TLS configuration, and then we will demonstrate the deny webhook and the add label webhook, but you can see that you can have multiple webhook implementations within a single server, as it is just a server. Inside of this implementation, you can see where we copy the UID from the response to the request. And so for the always deny, there is a very small implementation which sets to the review response to false, and again, importantly, as mentioned earlier, it sets a message. The label will add a label called added label to the created resource. So if we look at the configuration here, I have set up a Kubernetes server with 2 nodes, and so we can check that there are kube control get missed it. We have no webhooks created. So I will set up where is the one that I was using? This one. We will set up the webhook. And so now if I pull the webhook configuration, we can see that it's created. And to demonstrate that it's working, we will run a pod, and we can see that we got the message. So now, so that is the end of the demonstration. We will discuss some wrap up here, where I want to leave you with some advice. on webhooks and their side effects. And so you should be, in general, avoiding side effects. And what I mean by side effects is you shouldn't be writing to other objects that are not the object that you're being passed in. And the reason is you want to avoid having to keep track of state, because again, most of these controllers should be fairly stateless, and that if you interrupt them and restart them, they should be able to achieve their goals in the end. There are many different security aspects beyond the TLS that you should be aware of. If you're running your webhooks in the cluster, which you can run them in the cluster or out of the cluster, again, it's a REST API endpoint, anywhere you can contact it. You should probably have it in a separate namespace. You should have RBAC to configure access to your config objects, and you should understand the different failure modes that exist when you have the failure policies. So if your failure policy is set to ignore, you may end up skipping some kind of policy that you must have by corporate dictate. And so it's important to understand those policies. And again, as it is a separate web server that you're running, you can write it in any language you want as long as you fulfill the API, which is a REST API. You have the admission review filled with request and response. It's important, and as we mentioned, the other things to remember, that the order is not guaranteed, remain idempotent, and etc. And with that, next, we are over, and we would accept questions, I suppose. Thank you for watching, attending. Goodbye.
We cannot hear you.
Okay. Can you guys hear us?
Super. Okay. So other than a couple of questions on where are the slides, which hopefully I've posted a link. A good one, I think, is there a good code generator or starter projects for building new admission controllers? And I don't know if any of the Cube Builder stuff is set for specifically admission controllers, but the AGN host image that I was showing earlier on, I think, is a good. While it's sort of overcomplicated in that it's got 15 different admission controllers in it, it does have a very good run through of most of the features, and those are all tested using the integration testing that Kubernetes does. We wanted to sort of provide a sample one, but AGN host does really everything we wanted to do at the time. All right, Srini, the other one, there's a new one. Can you elaborate on what the reconcile process is for dry run on an object? We've been using validating webhooks that didn't allow for a dry run, but couldn't understand the implications of enabling it. So dry run, the idea there is that you want to support the object, you want to support looking at an object without actually creating it and persisting it through the whole stream. And so from what I remember, I think we didn't talk about this a lot, is that dry run has, there's a flag that you can put on the incoming object that says, is this a dry run object? And that means that you're just asking the server to basically do whatever it does and not actually persist all the objects. And so there are this is one of the reasons why we say sort of avoid side effects. if you're going to create side effects, which means you're going to go back and create new objects, you need to be worried about the modifications that happen to the incoming object that might be created, and then you don't want to leave these other objects around. So, by supporting dry run, you want to make sure you have a code path that goes through the full life cycle of a request, but doesn't actually create any of the ending objects. And maybe we can talk about that later.
Yeah, typically the validation webhooks cause any side effects. So.
And I don't see any questions that we haven't answered that aren't, where are the slides? And I don't know what any of these other buttons do, so.
Yeah.
Srini, do you have anything you want to add?
No, there are surprisingly there are other talks around security policies using admission controllers. So in this KubeCon actually for people to refer to if you're interested. The other thing is that thank you all for joining. Even though it's a virtual conference, we appreciate the interest. I see that.
Yep. And go stop by the virtual booths and get some virtual prizes. I think there's actually real prizes still, so stop by the IBM booth, I guess. And I hope you enjoyed some of the keynotes, and I hope you're having a good time, and I hope you're all safe and sound.